At this point, we're ready to just tackle the general case of, well, we're ready to see what happens when we're looking at these linear, constant, second order, ordinary differential equations with constant coefficients. So we're ready to tackle what happens. And what we're going to do is I'm going to show you how to derive the solutions here. What's a little bit beyond this course is I'm not going to show you that these are the only solutions that we're going to have. We'll actually have the tools to do that later, but for now, you can just trust me that we're just going to find two linearly independent solutions to this differential equation, no matter what A and B are. So what I want to do is I want to make a guess that our differential equation is going to look something like y equals e to the r x. Okay, so that's what we're going to guess. And we want to figure out, if we can figure out what our the value of r is that's going to allow us to solve this, then we should be good to go. We know how to deal with finding the general solution if we have other solutions. So what I want to do is I want to compute y prime and y double prime. Y prime is, of course, r e to the rx. Y double prime is r squared e to the rx. And then I'm going to plug this back into the differential equation. And when we do this, that makes our differential equation of the form r squared e to the rx plus a times y prime, which was r e to the rx, plus b, which was e to the rx, equals 0. And of course, we can factor out an e to the rx from both sides, well, from the left side, and then divide both sides by that. And we're left with this equation. If we divide both sides by e to the rx, by the way, we're allowed to do that because e to the rx is never 0. And so that leaves us with the equation r squared plus ar plus b equals 0. And sometimes that's called the characteristic equation of that differential equation. And what this means now is that if we want to solve the differential equation, we've just transformed this into a high school algebra problem. You just have to figure out what are the solutions to this quadratic equation. This is quadratic in R. What are the solutions to that equation? And of course, you have the quadratic equation to tell us what happens. Well, there's going to be three cases. There's three cases. The first case is if let's call the two solutions R1 and R2. So if we have two real solutions, R1 and R2, okay? Maybe it's like 1 and 4 like we had for our example before. But if we have two real solutions, then the general solution is just going to be C1 e to the R1x plus C2 e to the R2x. So if we go back and if we look at our example, I just gave you the solutions before, but if we go back and we look at our example one last time of looking at y double prime minus, let's make that a little bit more readable, y double prime minus 5 y double minus y, y double prime minus 5y prime plus 4y equals 0. What we were really looking at was the equation r squared minus 5r plus 4 equals 0, and the solutions were r equals 1 and r equals 4, because this factors as r minus 1 times r minus 4. And that means that we had c1 e to the 1x plus c2 e to the 4x as our general solution. And that's exactly what we found as our general solution. If we were to have something like y double prime minus 8y prime plus 15y equals 0, what would happen is we would look at the equation r squared minus 8r plus 15 equals 0. This is going to have solutions of r equals 3 and r equals 5 because its factors is r minus 3 times r minus 5. And that means that our general solution then, so our general solution is going to be y is going to be c1 e to the 3x plus c2 e to the 5x. That's the end of the story. Really not much more that we need to say there. We'll do some examples as we go along, but that's the first case. Okay. The second case is we could have one real solution. Okay, so you could have one real solution say R naught. Okay, and so what this means is that this is one real solution of multiplicity 2. The way that this happens is if you were to have something like y double prime minus 4y prime plus 4y equals 0. And if you look at the equation, you'd have r squared minus 4r plus 4 equals 0. This becomes r minus 2 squared equals 0. And so that tells us that our solution is going to be r equals 2, because that's the base here, of multiplicity 2. So it's a solution twice, because we have that square. And it turns out that when you have a real solution r naught, your general solution, so your general solution, is going to be, you're going to have c1 e to the r naught x plus c2. You can't just put another e to the r naught x there because those are not linearly independent. But if you put an x in front, then they are linearly independent. And if you put an x in front, this turns out to satisfy the same differential equation. So if you were to put in, for this particular example, you would end up with y equals c1 e to the 2x plus c2 x e to the 2x. And it turns out that's how you're going to find your general solution if you have just one repeated root. So for example, let's do it down here so that there's room. Let's solve y double prime plus 10y prime plus 25y equals 0. And that's going to lead us to solving the algebra equation r squared plus 10r plus 25 is 0. And that means that your solution is going to be r equals -5 of multiplicity 2. And therefore, your general solution is going to be c1 e to the -5x plus c2 x e to the -5x. And that's how we'll deal with that. And then finally, the third case is if you have two complex solutions. Okay, and so before we talk about how to handle what happens when you have two complex solutions to this equation, we have to figure out what is e to a complex number, and we'll do that in the next video.